but find Raymond's, not Darbox sum. Yesterday we have seen Darbox. The partition 0, 1, or you can have 3 by 2, 2. Let us. Then how to find out Raymond's for this partition? So how to find Raymond's sum? You should know, and I should give you what is tag. Tagged it. This will be given to you. Tagged it. Left it, for example. 2 bits second. Any number of bits second. Tagged it. Right it. Tagged at midpoint. Can be tagged at any point. Tagged means take it as either left hand or right hand. So let us try to find out for this. So earlier we found increasing, decreasing, finding derivative. This is not differentiable at all. So f of x is box. The partition given is 0, 1, 3 by 2, 2, 3. Now first interval 0, 3. Second interval 3 by 2, 2. Third interval 2, 3. Now, if I tag it first bit, for this deltas are the same, 3 by 2. Delta 2, 2 minus 3 by 2, 1 by 2. Delta 3, 3 minus 2, 1. Now, we have to find xi1, xi2, xi1. For the first bit, left hand, what is my xi1? Is tagged at left hand. Left hand means this. For this, the tagged at left hand is 1.5. 1.5. Tagged at left hand, that is 2. If it is tagged at right hand, then it will be 3 by 2, xi1. Tagged at right hand, xi2 will be 2. Tagged at right hand, this is right hand, so xi3 will be 3. Midpoint, what will you get? Xi1, 0 plus 3 by 2 by 2. Whatever you get, 3 by 4. Then, if it is midpoint, what is midpoint? 3 by 2 plus 2 by 2, that is 7 by 4. Midpoint, 2 plus 3 by 2, 5 by 2. That will be the tag. So, I am showing for 1, remaining to homework. Next, what we have to do, f of xi1 we have to find. So, what is f of xi1? What is fx? Box x. What is f of xi1? F of 0, box 0. Box of an integer is itself, you know. Next, f of xi2. F of 3 by 2. Box 1.5. How the box is defined? Only integer part. We have discussed there are 2 to 3 definite. So, 1 integer part, which is 5. F of xi3. F of 2. Box 2. Which is 2 itself. Box of an integer is itself. Now, let us go for SPF. F of xi1 into, what is the formula? F of xi r delta. R ranging from 1 to n. Here only 3 are. So, f of xi1 into delta 1. F of xi2 into delta 2. F of xi3 into delta. So, what is f of xi1 is 0 into delta 1. What is delta 1 for this is, for the first interval, delta 1 is 3 by 3 by. F of xi2 is 1, delta 2 is 1 by 2. F of xi3 is 2, delta 3 is 1. You can see the values. Delta 2 is 1 by 2, delta 3 is 1. Now, this is 1 by 2 plus 2. That is 5 by 2. This is the required Riemann sum. So, I think you can do further review. So, here we have not used any differentiation, any continuity. Simply, we used the definition and tag. So, tag exists for all. So, this has solved many questions. Because if you want to find integral of mod x, mod x is not continuous because it is having a breakpoint at 0. It is continuous but not differentiable, but still integral exists. Similarly, box x is neither continuous nor differentiable, but still integral exists. You know how to calculate. Actually, I have shown you. Then it is, how is it connected to this Riemann concept is, it is following second definition. So because of that, we could show that it exists. And what is the value we could. Okay. So this is how first and second will give you the same. Definition 1 is equivalent to definition 2. So if somebody is extending any concept in the research, if you substitute something, it should not contradict the previous research. For example, Cauchy integral formula. Cauchy integral formula for derivatives. He only invented Cauchy only. So in the derivatives formula, if you take as a special case, when n is 0, it should give you the continuity formula, Cauchy residue theorem. It should not contradict the superior one. When somebody is progressing in the research, if you substitute something as a special case, it should not contradict the previous theorem. So it's an extended concept. So Riemann first and second will give you unique answer, integral a to b fx dx. Okay, this is the. Next, we have a theorem called fundamental theorem of integral calculus. We have done Leibniz. Then many of you must be getting doubt. Your teacher told this fundamental theorem of integral calculus. That is, integration, differentiation disappears. When it disappears, then where is the question of value? Many of you must be getting doubt. So before going to this, till now we have done only definite integral. Then how indefinite integral concept is developed is, so Riemann, he introduced a concept called primitive. What is primitive is, if phi is a differentiable function such that phi of x is equal to f dash of x or phi dash x equal to f of x, then phi of x is what is called primitive of fx. What is phi? Any differentiable function. I'm not defining formalities because yours is MCQ. I'm not following. If pure mathematicians are there, please understand. I'm doing MCQs. I'm not writing total statement. The total statement you have to write actually. So phi dash of x equal to f of x. Phi is a differentiable function. Always pure mathematicians will be always after, is it continuous or not, is it differentiable or not, small details. But the application point of view, applied mathematicians, they don't care for the formalities. For example, Fourier integral formula, Descartes, Fourier, Newton, there are physicists. So applications, there are applied mathematicians. They don't care whether it is continuous or not, like that. Simply they give the formulas and do the application. But now, so please, pure mathematicians, if any one of you are there, please, you should not have any objection for the way I am doing. Because it is application, I'm not concentrating on the basic things like pure maths people will concentrate. So if phi is differentiable on the closed interval, and on this interval for every x on the interval AB, phi dash x is fx, then phi x is what is called primitive of fx. And it is also denoted by, it's nothing but integral fx dx plus c. In other words, this is how indefinite concept has arrived. Indefinite integral, because c is there, no limits. So how do we do the integration then? So what is the link between, for example, what is the primitive of? Primitive of x square is, how do you get primitive? This is nothing but small fx. How to get primitive? Primitive means phi of x, which is integral x square dx plus c. That means when you differentiate this function, you should get back this. So if you differentiate, you get 3x square by 3 cancels. Constant derivative is 0, so x square. So phi of x is this. This is what is called as the primitive of x square. So sometimes you'll be asked to identify which of the following is the primitive. The primitive of x square is, options will be given to you. x cube by 3 plus 1, x cube by 3, x cube by 3 plus constant. So if it is more than one correct option, these also correct, these also correct, these also. Because if you give c equal to 0, you will get 1. C equal to 0, this, c equal to 1, this. C can be anything. So how many primitives exist is infinitely many. When you differentiate this, you should get back this. When do we call this as primitive? If you differentiate this, you should get back this. Differentiate this, you'll get back. Differentiate this, you'll get back. So the primitive of this is all are primitives only. So primitive is not unique. This is how Riemann has developed indefinite integral. So our journey is from definite to indefinite. But in the intermediate, how you did indefinite to definite. Reverse process because of Newton's approach. This is Riemann effect. Next, we have fundamental theorem of integral calculus. So if phi is differentiable function, derivable on AB, and f is integrable on AB, then fundamental theorem of integral calculus says integral a to b phi dash of x dx is equal, or in other words, phi dash x is nothing but phi is primitive of f. Then integral a to b phi dash x dx is fb minus integral a to b phi dash of x is nothing but phi b minus phi. What is phi dash x? Fx dx. Fx dx is nothing but, because it is primitive, f is integrable, so I can talk about this. Because it is primitive, fx is nothing but phi dash x, phi b minus. So here, your teacher told in your intermediate, integration and differentiation opposite operators, they cancel. But I have given in Leibniz, they don't cancel it. Because they're constants and derivative is outside. Here, derivative is inside. So they are not always interchangeable. So if they are outside, then need to go for Leibniz. So different formulas we have seen under Leibniz. This is not Leibniz. Derivative is inside. For Leibniz, derivative is outside. So this is phi of x dx. Integration differentiation cancels, your teacher told. Then phi of x remains. Upper limit minus lower limit, that will give you this. So it will not disappear. Answer is not 0. They are opposite, correct. But this contribution will be upper limit minus lower. So this is what is called fundamental theorem of integral calculus. So let us go for now. This is, you may be asked to identify what is fundamental theorem. So let us go for now. Some properties which you have done integral calculus, that I am not entering into that. Problem oriented you have completed. I am doing only Riemann integration. Your ordinary integration you have mastered in your intermediate. So that you can do. Now I will enter into Riemann-Sutlerge integral. Where is the necessity to go for Riemann-Sutlerge? So using Riemann, you can calculate only integral fx dx. You cannot do fx dx square. You cannot do. Fx d mod x, you cannot do. So if it is x only, you can do. But Riemann has extended, Sutlerge has extended the Riemann concept to some function, not only x. If there is x, why cannot we do for x square? Why cannot do for e power x? Why cannot do for sin x? We can have here instead of x any other function. So he extended the concept that is given by Riemann-Sutlerge integral. So both together have invented this concept, Riemann-Sutlerge integral. Sutlerge integral. Riemann-Sutledge integral concept, extent. Only application I am doing. So, important statement is, if f is Riemann integrable on AB and alpha is monotonically non-decreasing, monotonic non-decreasing. So you may sometimes be asked to state under what conditions. Is it applicable for all alpha, or what are the conditions that should be imposed on alpha? That should be clear. Non-decreasing. Non-decreasing does not mean increasing. Non-decreasing means it may be increasing or it may be constant function also. Function on AB. Not passed does not mean failed. Is it not? Not passed does not mean failed. Might have been withheld or missed, debarred, any other. Not passed means not one failed. Similarly, non-decreasing does not mean increasing. It may be increasing or constant also. So be careful on AB, such that conditions are very important. Theorems as it is, you have to write. You should not write in your own words. Alpha dash is Riemann. Nothing is said about alpha. Alpha dash is Riemann integrable. Then F, we say it is Riemann integrable with respect to alpha and is defined by integral a to b f d alpha is equal to integral a to b fx alpha dash x d. What is d of alpha? D means differentiation. What is d of alpha x? For derivative of alpha is alpha dash x into dx. So because variable is x, that's how this is defined. This you know how to do. UV formula of your interval. So whenever you get fd alpha, it is fx into alpha dash x. How do you know it is differentiable? Alpha dash is integrable. So alpha dash x into dx. So whenever you get any other function, use this. For example, integral, I will work out one interesting question based on this, which you might not have seen. I want to work out one such question. Box 6, 0 to 3, box 6, D, x, dx. So some students, what they do is, they think it is some mistake in the question. Because if you don't know some Riemann-Sutledge, if you don't have that idea, what you will do, you will adjust yourself. Maybe question incorrect. So you will correct the question and you will do it. You think it is x into box x into dx and you start doing, you will get some answer. That will be your first option. Parasitic situation is that 99% of the students, they mark first option, taking this as x. They think something wrong in the question. There is not. Question is not incorrect. It's correct. Because instead of alpha, you are having x. First time, some of you must be saying. First, you have to convert this into. So instead of x, you may have any other function that is also defined. First, transform the problem into standard form. Box x into x square is differentiable. Box x is not differentiable. X square is differentiable. What is the derivative of this? Is 2x. Because alpha is x square. Alpha dash is 2x. That. So alpha dash x into dx. This is the formula. Now you know this, you know how to do it. 0 to 3, x box x to dx. So where to break? Box x is discontinuous at every integer. What are integers between 0 to 3? Between 0 to 3, including 0 and 3, integers are 1 and 2. So break at every integer point. 0 to 1, x box x. 1 to 2, x box x. 2 to 3, x box. Yesterday I have defined excluding upper limit. Always exclude upper. So this is 2 into. box x. First you have to simplify, then only apply. So what is box x? Let us do roughly. Box x in between 0 to 1. Exclude upper limit. In between 0 to 1, there is no integer except 0. So 0. Between 1 to 2, what is the only integer? 1 is the only integer between 1 to 2, including 1. 2 is not included. So greatest is 1. Between 2 to 3, greatest integer in this interval, including 2, excluding 3, is 2. Let us use. This means x greater than or equal to 0, less than 1. This means x limits are greater than or equal to 1, less than. This means x greater than or equal to less than. So simplify box x. So 0 to 1, x into box x is 0. 1 to 2, box x is 1. 2 to 3, box x is 2. So 2 into, this is 0. This is x 1 to 2. 2 into x square. If you are doing for descriptive, don't do like this. Do as given in the text. Apply fundamental theorem and then do it. But now this is MCQ, so I'm skipping this. 2 minus. Anything wrong? Anything wrong? This is 2.
Madam, second function x into 1 and x out, x square by 2 with limit 1 to 2.
X into 1, x into 1, x square by 2. Third one, this is 2 into x, so 2x square by 2. So here I will get 2 square by 2 minus 1 by 2. This is 3 square minus 2. This is 2 into 4 by 2. 4 by 2 minus 1 by 2. That is 3 by 2. 4 by 2 minus 1 by 2 is 3 by 2. 9 minus 4, 5. This is 2 5s are 10, 13 by 2. 30. Hopefully correct. Any mistakes? Just check. Okay. This is how you can apply Raymond's atlas. This is one of the best applications. Box x, dx. So you can apply your UV techniques whenever you want to. So homework is 0 to 3, box x, d e power x. What is d e power x means? The alpha is e power x, so e power x dx. Apply. Okay, try to practice this. Next, let us go for another application of Raymond's at large. This is only when alpha is differentiable.